Hello and welcome to Algebra 1 Test Section 1 on solving quadratic equations by factoring. All right, so we want to solve each quadratic equation by factoring. And we're going to take a look at v squared minus 4v minus 5 equals 0. So the first thing we want to do is make sure that it's in standard form. So remember, this is ax squared plus bx plus c equals 0. And this is already in standard form. This already matches this description. So once we've done that, all we need to do is factor the left side, set it equal to 0. So let's go ahead and do that. So we're going to factor the left side, set it equal to 0. And so we know this would be v here and v here. And if I have two integers that sum to -4 and have a product of -5, what would they be? Well, it would be a +1 and a -5, right? +1 and -5. 1 times -5 is -5. 1 minus 5 is -4. So that works out. Now we're going to use our zero product property. So remember, that's if you have a times b, and that's equal to 0, then either a is 0, b is 0, or a and b are both 0. So what I'm going to do is use that property to say, okay, if the quantity v plus 1 times the quantity v minus 5 is 0, then either this factor, v plus 1 is equal to 0, or this factor, v minus 5 is equal to 0, or they both are. So all I need to do is solve each of these for v, and I'll have two potential solutions to check. So I'm going to subtract 1 away from each side of the equation here. I'll have v equals -1. I want to add 5 to both sides of the equation here, and I'll have v is equal to 5. So I get v equals -1 or v equals 5. So let's check these in the original equation. So if I plugged in a -1 for v, I'd have the quantity -1 squared, right? I'm plugging in a -1 for v, so that's why I'm using parentheses, minus 4 times -1 minus 5 equals 0. So I'd start out with -1 squared, that's 1. And then we'd have -4 times -1, that's +4. And then minus 5 equals 0. So now 1 plus 4 is 5. 5 minus 5 is 0. So we get 0 equals 0. So this first guy is going to check out. V is equal to -1. Now let's check out the second guy where v is equal to 5. Okay, v is equal to 5. So 5 squared is 25. And then minus 4 times 5 is 20. Then minus 5 should be equal to 0. 25 minus 20 is 5. 5 minus 5 is 0. So you get 0 equals 0. And so I'm going to check mark this one as well. So v is equal to -1 or v is equal to 5. And as I taught you in the lesson, you could also write this in solution set notation with your set braces. And inside you have -1, 5. All right, what about b squared minus 2b plus 1 is equal to 0? So it's already in standard form, so we just need to factor the left side. And one thing you might notice right away is this is a perfect square trinomial. So if I factored this, I know it would be what? It's b minus 1 squared, right? This quantity squared. Or I could write b minus 1 times b minus 1, right? Those two quantities. So this equals 0. And since I have the same thing here, I'm only going to have one potential solution. So it would just be b minus 1 equals 0. One of these. Because if I had a times a equals 0, I have the same thing times itself. I basically have a squared equals 0. And so I know that a has to be 0 in that case for that to be true. So it's the same thing here. It's not like I have two different scenarios. I only have one. So I would add 1 to both sides of the equation. Now we get b equals 1. And that's my solution, right? b is equal to 1. Let's erase this, and we will check it. So if I plugged in a 1 there, I'd have 1 squared minus 2 times, plug in a 1 there, plus 1 equals 0. 1 squared is 1, so you'd have 1 minus, 2 times 1 is 2, plus 1 equals 0. 1 minus 2 is -1, -1 plus 1 is 0, so you get 0 equals 0. So yeah, this is true. b does equal 1. Hello and welcome to Algebra 1 Test Section 2 on solving quadratic equations by factoring. All right, so we want to solve each quadratic equation by factoring. And we're going to start out with v squared plus 40 equals 13v. So we want to start out by putting this in standard form. So we want ax squared plus bx plus c equals 0. So to get this in standard form, I just need to move this over here. And so what I do is I would just subtract 13v away from each side of the equation. So minus 13v and then minus 13v. So I would write this as v squared minus 13v plus 40 is equal to 13v minus 13v is 0. Okay, let's erase this. Now I want to factor the left side and set this equal to 0. So we know this is going to be the product of two binomials. This will be equal to 0. And I know this will be v and this will be v. So how do I get these two parts here? Well, I'm looking for two integers whose sum is negative 13 and whose product is 40. So if I think about that, for 40 I have what? I have 1 times 40. I have 2 times 20. Not divisible by 3, I have 4 times 10. I have 5 times 8. Now 5 and 8 I could make that work. If I had negative 5 plus negative 8, that's negative 13. Negative 5 times negative 8 is 40. So negative 5 and then negative 8. Now, what I want to do, I want to use my zero product property. So that tells me if I have two numbers, let's say a and b, and they're multiplied together and they equal 0, then a can be 0, or b can be 0, or they're both 0. It's got to be one of those scenarios, right? Because if you get 0 as a result, it means one of those at minimum had to be 0. So we use that same principle here. One of these factors, I have the quantity v minus 5, and I have the quantity v minus 8. One of them has to be 0. So to figure this out, we set each factor equal to 0. So v minus 5, that's going to be equal to 0. And then we can say or v minus 8, we set that equal to 0. We solve each for v. So plus 5, we'll get v equals 5. Or we'll add 8 to each side here. We'll get v equals 8. So v equals 5 or v equals 8. Okay, so let's check this guy now. So I'm going to start out by plugging in a 5 for each v. So I would have 5 squared plus 40 is equal to 13 times 5. 5 squared is 25, so I'd have 25 plus 40 is equal to 13 times 5 is 65. 25 plus 40 is 65, so you get 65 equals 65. So the first guy checks out. Let's check out the second guy. So let's erase this and this. And I'm going to plug in an 8 here and also here. So 8 squared is 64, so I'd have 64 plus 40. And then 13 times 8 would be 80 plus 24. That's 104. So 104. And then 64 plus 40 is also 104. So you get 104 equals 104. So this checks out as well. So we get v equals 5 or v equals 8. And again, as I showed you in the lesson, you could write this in solution set notation as put your set braces, 5, 8, kind of close that up. So again, v equals 5 or v equals 8. All right, for the next one, we have k squared plus 10 is equal to negative 7k. So let's add 7k to both sides of the equation. So we would have k squared plus 10 plus 7k is equal to 0. And I'm going to rearrange the order here because remember, we want this to be ax squared plus bx plus c. I want it to look like that and then equals 0. Same thing as if you had standard form for a polynomial, right? You want descending order of power. So k squared, then k to the first power, then your constant. All right, so let's factor the left side here and set that guy equal to 0. So I'd have k and k. So give me two integers that sum to 7 and have a product of 10. That's easy, that's 5 and 2. And so I'm going to set each one of these equal to 0. So k plus 5, set that equal to 0. And then also we'll set k plus 2, that equal to 0. And then I can eyeball this and see that the answer would be k equals negative 5 or k equals negative 2, right? But for the sake of completeness, let's subtract 5 away from each side. Again, k equals negative 5, or let's subtract 2 away from each side, k equals negative 2. So k equals negative 5, or k equals negative 2. All right, so let's check each one now. So if I plug in a negative 5 for k, I'd have negative 5 squared plus 10 is equal to negative 7 times negative 5. Negative 5 squared is 25, so 25 would be added to 10, that's 35. Negative 7 times negative 5 is 35, so the first one checks out. The second one, k equals negative 2. Let's plug in a negative 2 in each position. So this will be here and here. Negative 2 squared is 4. 4 plus 10 is 14. Negative 7 times negative 2 is also 14, so this one checks out as well. Hello and welcome to Algebra 1 Test Section 3 on solving quadratic equations by factoring. All right, so we want to solve each quadratic equation by factoring. And we're going to start out with 7x squared equals 28x minus 28. And remember, we want to start by putting the equation in standard form. So I want ax squared plus bx plus c is equal to 0. So that means I'm going to subtract 28x away from each side of the equation and add 28 to both sides of the equation as well. So minus 28x minus 28x plus 28 and plus 28. Right, it's going to go on this side. So I'd have 7x squared minus 28x plus 28, and this would be equal to 0. Right? 28x minus 28x is 0. Negative 28 plus 28 is also 0. So let's erase this real quick. And when I look at this, it looks like one of the harder type trinomials to factor. But then I start thinking about this. I can pull a 7 out from everything. And if I do that, I'll have 7 times x squared minus 4x plus 4. And put equals 0. And I notice this is a perfect square trinomial. It's going to be really easy to factor this. So it's going to be 7 times x minus 2, that quantity squared, or I can put 7 times, we have x minus 2 times x minus 2, and again, this is equal to 0. So in most situations, when we use something called the zero product property, we end up with two potential solutions. Here I just have x minus 2 that's duplicated. Normally when we talk about the zero product property, you see me write, okay, a times b is equal to 0, and I'll tell you that either a has to be 0, or b has to be 0, or both a and b are 0. Right? If you multiply something by 0, you get 0. So one of those has to be 0, or they're both 0. In this particular case, you look at your factors. 7 can't be 0. You're only thinking about things that have a variable involved. X minus 2 could be set equal to 0. So x minus 2 could be set equal to 0. But the other thing is x minus 2. So if I get a solution for this one, it's also a solution for this one. They're the same. So I just have one potential solution here. So I add 2 to both sides of the equation, and we get x is equal to 2. So let's plug that in and check. So we'd have 7 times 2 squared equals 28 times 2 minus 28. So 2 squared is 4. 7 times 4 would give me 28. And this is equal to 28 times 2 is 56. 56 minus 28 is 28. So 28 equals 28. So yes, this is the solution. And again, if you want to write this in solution set notation, just throw your 2 inside of some set braces. Either way, you can show that x is equal to 2. All right, so now let's look at 5a squared equals 15a. And again, I want this to look like this. ax squared plus bx plus c equals 0. So I could subtract 15a away from each side of the equation. And I get 5a squared minus 15a is equal to 0. Now you might think that, okay, this has 3 terms on the left side. This has 2. I could put plus 0 over here. That could be my c term. But I don't need to do that, right? If I simplify it, it'd just go back to this. So let's erase this real quick. And now you might say, well, how am I going to go about factoring the left side? That's not a trinomial. Well, always think about what you can pull out. And if you have a prime polynomial, something that can't be factored, then you're not going to be able to solve a quadratic equation using this method. But in most cases, if you're on this section, they're not going to give that to you. So there must be some trick. So I know that 5a is common. So let me pull that out. So I can pull out a 5a. And then what's left is a minus 3. So if these are my two factors, I could set each one equal to 0. I could say, okay, well, 5a is equal to 0. Or we could have this quantity a minus 3 is equal to 0. Right? And I take the parentheses away, and I could solve that by adding 3 to both sides of the equation. So this is a is equal to 3. And over here, this one's obvious. A would be 0, right? If I divide both sides by 5, I would get a is equal to 0. So we get a is equal to 0, or a is equal to 3. So if we wanted to check this, again, we'd plug a 0 in for each a. Plug a 0 in here and here. We know we get 0 equals 0. That's easy enough to check. You can just eyeball that. If I plugged in a 3 here, I'd get 3 squared, which is 9. 9 times 5 is 45. So that'd be 45. And over here, 15 times 3 is 45. 45 equals 45. So that works out as well. So A is equal to 0 or A is equal to 3. Again, in solution set notation, this is 0, 3 inside of set braces. So either way you want to display it, A equals 0 or A can also be 3. Hello and welcome to Algebra 1 Test Section 4 on solving quadratic equations by factoring. All right, so we're going to solve each quadratic equation by factoring. And we're going to take a look at 6x squared plus 23 is equal to 19x plus 8. So the very first thing we want to do is we want to put this in the format of ax squared plus bx plus c is equal to 0. Right, this is the standard form. So what I do here is subtract 19x away from each side, and I'd also subtract 8 away from each side. So when I do that, I'll have 6x squared minus 19x, and then I have 23 minus 8. That's going to give me 15, so plus 15. And then this equals 0. I can erase all this, and I can erase this. So now it's in standard form, and all I want to do is I want to factor the left side and set it equal to 0. Now this one's a little bit more difficult to factor because the coefficient on the squared variable is not 1. So I taught you in a previous lesson how to factor these. You can use reverse FOIL, or you can use kind of factoring by grouping. I like to use factoring by grouping, so let's go ahead and do that. So I want two integers whose product is 6 times 15 or 90. And whose sum is negative 19. Now if I have a positive product and a negative sum, must mean that I have two negatives involved. So let's think about absolute values for a second. For 90, the factors would be 1 times 90. That's not going to work. 2 times 45, that's not going to work. 3 times 30, that's not going to work. It's not divisible by 4. 5 times 18 would not work. 6 times 15 would not work. Not divisible by 7. Not divisible by 8. It is divisible by 9. And 90 divided by 9 would be 10. So 10 and 9 would work. If I did negative 10 and negative 9, negative 10 times negative 9 is positive 90. Negative 10 plus negative 9 is negative 19. So let's go ahead and use that to rewrite the middle term. So we'll have 6x squared minus 10x minus 9x plus 15 equals 0. So I'm going to factor this by grouping. In the first group, I can pull out a 2x. And that will leave me with 3x minus 5. In the second group, I'm going to pull out a negative 3. And that's going to leave me with 3x minus 5. So the common binomial factor is 3x minus 5. So we're going to factor that out. And so what I'll have is 3x minus 5 times 2x minus 3. And again, this equals 0. So now we're at the stage where we can use our zero product property. So recall that tells us that if we have two numbers and they're multiplied together to give us 0, then one of those numbers has to be 0 at minimum, right? One of them can be 0 or both of them can be 0. So formally, we generally see A times B is equal to 0. And we'll say, okay, A times B can equal 0 if A is 0 or B is 0 or both A and B are 0. So here, following that same format, the quantity 3x minus 5 times the quantity 2x minus 3 is equal to 0 if 3x minus 5, this is equal to 0, or 2x minus 3 is equal to 0. So let's solve each one for the x value that would make that particular binomial equal to 0. So for this one, I would add 5 to both sides of the equation. I would get 3x is equal to 5. Divide both sides by 3. You get x is equal to 5/3. For this one, I would add 3 to both sides of the equation. I would get 2x is equal to 3. Divide both sides by 2. You get x is equal to 3/2. So what I have is x equals 5/3 or x equals 3/2. So let's check each one and see if they work. So we will have 6 times, plug in a 5/3 for x, and this is squared, plus 23 is equal to 19 times 5/3 plus 8. So if I start off with 5/3 squared, I would have 6 times 25/9. Now I can cancel a common factor of 3. So this would be 2 and this would be 3. So I'd end up with 50/3. So 50/3, then plus 23 equals, if I have 19 times 5, that's 95. So this would be 95 over 3. Then plus 8. Now, I can get common denominators, or I can just multiply everything by 3. So in other words, if I multiply, since it's an equation, if I multiply everything by 3, according to the multiplication property of equality, I'm still good to go. So if I multiply this by 3, I'd get 50. Then plus, if I multiply 23 by 3, I'd get 69. This should be equal to, if I multiply this by 3, I get 95. If I multiply this by 3, I get 24. So 50 plus 69 is 119, is equal to 95 plus 24 is also 119. So you get 119 equals 119. Scroll back up here, and we could say that x equals 5/3 is a true solution. All right, now let's check 3/2. So 3/2 squared is going to be 9/4. So you'd have 6 times 9/4. Can cancel a common factor of 2. So this would be 3 and this would be 2. So what I'd have is 27/2. So 27/2 plus 23 is equal to, for this one, 19 times 3 is 57. That over 2, so 57/2 plus 8. So again, I can get common denominators going, or I can just multiply everything by 2. So if I multiply this by 2, I get 27. If I multiply this by 2, I get 46. If I multiply this by 2, I get 57. If I multiply this by 2, I get 16. So 27 plus 46 is 73. And 57 plus 16 is 73 as well. So again, this right here, x equals 3/2, is also a solution. So I can also write this in solution set notation. So inside of set braces, I can write 3/2, 5/3. Hello and welcome to Algebra 1 Test Section 5 on solving quadratic equations by factoring. All right, so we want to solve each quadratic equation by factoring. So we're looking at 19x squared minus 180x minus 160 is equal to negative 6x squared. So the first thing we want to do is write each equation in standard form. So that looks like this. We have ax squared plus bx plus c is equal to 0. So I'm going to add 6x squared to both sides of the equation. And what that's going to give me is 25x squared minus 180x minus 160 is equal to 0. So I notice right away that everything's divisible by 5. So let's pull that out. And I'll have 5x squared minus 36x minus 32. Okay, this is equal to 0. And now I want to factor what's inside. So let's go ahead and factor this. So I want two integers whose product is 5 times negative 32, which is negative 160. This is my product. And whose sum is negative 36. This is my sum. So let's think about the factors of 160. So it's obviously not 1 times 160. It's not 2 times 80, but 4 times 40. You could make 4 and 40 work if the signs were right. If I had negative 40 and plus 4, that would work. So I'd have 5x squared minus 40x plus 4x minus 32. Let me erase this. I don't need this anymore. And this is equal to 0. So now I'm going to factor by grouping. So I'd have 5 times, inside of parentheses here. If I pulled out a 5x from the first group, I would have x minus 8. Then plus, if I pulled out a 4 from the next group, I would have x minus 8. This equals 0. And so now I can pull out the common binomial factor of x minus 8. And I'd be left with 5x plus 4. Okay, this equals 0. So then now once I'm in this stage, each factor would be set equal to 0. Now 5 wouldn't be set equal to 0 because obviously 5 isn't equal to 0, but each factor with a variable would be set equal to 0. Remember the zero product property. If I have a times b, and this is equal to 0, then it's got to be true that either a is equal to 0, b is equal to 0, or both a and b are equal to 0. Well, in this case, it's got to be true that x minus 8 is equal to 0, or 5x plus 4 is equal to 0. So for this one, I just solve by adding 8 to each side of the equation, and I'll get x is equal to 8. Very, very simple. For this one, I'll subtract 4 away from each side. I'll get 5x is equal to negative 4. Divide both sides of the equation by 5, and I'll get x is equal to negative 4/5. So you get x is equal to 8, or x is equal to negative 4/5. All right, so let's check each one now. So we would have 19 times, plug in an 8 for x, so that's squared, minus 180 times, plug in an 8 for x, minus 160, and this equals negative 6, plug in an 8 for x, and then it's squared. All right, so 8 squared is 64. Then 64 times 19 is 1,216. So let's write 1,216. Then minus 180 times 8 is 1,440. Then minus 160. This is equal to 8 squared is 64. And 64 times negative 6 is negative 384. So if I just go left to right, 1,216 minus 1,440 is negative 224. And then if I subtract away another 160, I will in fact get negative 384. So I get negative 384 equals negative 384. And so we can say that x equals 8 is a true solution. All right, for the next one, I have x equals negative 4/5. So I would have 19 times, you've got negative 4/5 squared, then minus 180 times negative 4/5, then minus 160 is equal to negative 6. Again, plug in for x, so times negative 4/5, and this is going to be squared. All right, so negative 4/5 squared is going to be 16/25. So you'd have 19 times 16, which is 304, over 25. Here you've got negative times negative, that's positive. I know that 180 is divisible by 5. It will give me 36. So I ended up with 36 times 4, which is 144. So this is a plus 144. And then I have minus 160. Now, because there's a fraction involved here, to make this easier, let me just perform this operation. 144 minus 160 is just negative 16. So I'm going to put minus 16 here. This is equal to, over here, if I square this, I'm going to get 16 over 25. So negative 6 times 16 over 25. Negative 6 times 16 is equal to negative 96. You'd end up with negative 96 over 25. So there's two things I can kind of do here. I can get a common denominator going and perform the subtraction, or I can multiply both sides by 25. Same thing either way. If I multiply both sides by 25, I'm going to have 304 minus 25 times 16 is 400 is equal to negative 96. And you'll see 304 minus 400 is negative 96. So you get negative 96 equals negative 96. If I had got a common denominator going, it's the same thing, really. Multiply this by 25 over 25. You could end up with 400 over 25. And basically, I'd have negative 96 over 25 is equal to negative 96 over 25. So if we scroll back up, we could say x equals negative 4/5 is a solution. We could write this in solution set notation, negative 4/5, comma 8. So either way you want to display it, your answer is x equals 8 or x is equal to negative 4/5.